I said M17 2 to 1 second. So just give me 1 second. 17 question paper 2. Yeah. So let's start with this one. Okay, starting with the first question.
Sir?
Hanji.
So after the class, can you send the new schedule, whatever you want to follow?
हाँ ठीक है.
Oh.
ठीक है. मैं change कर लेता हूँ अभी show. Starting with the first question, complete a table to show the maximum oxidation number of each element in its compound. Mg is always +2, Al is always +3. Cl could be what? It could be Cl could be phosphorus could be +3 and also +5. He's talking about the maximum oxidation number, so we're going to go with +5. Sulfur can have many different oxidation states. If I write down all of them, H2S, it's -2. Sulfur could be 0 as well. You can have SO2 where it's +4. You can have SO3 where it's +6. So +6 is the maximum oxidation state, and chlorine over there is +7. As for the next one, explain why the atomic radius of the third period decreases from Na to Cl. Again, 3 mark. So what happens when you move to the right? क्या होगा? When you move
nuclear
to the
charge
right,
increases, shielding effect remains constant.
ठीक है, so your nuclear charge increases, more protons. So nuclear charge increases, and same number of shells. And that's why, so you're going to write, hence, because of all the above, there is more attraction between outer shell electrons and the nucleus. So size of atom decreases. Now, what's the next one? You've got the radius of the more common ion of Mg is much smaller than the radius of the most common ion of sulfur. So why is Mg smaller and sulfur bigger in size? But why is the radius of Mg smaller and the radius of sulfur ion bigger in size? क्या होगा? Mg loses its outer shell electrons. So it's obviously going to be smaller. It had 12 electrons, but now the outer electrons are gone. So it has lost one complete shell. So when it forms an ion, so the ion is obviously going to have a smaller radius, while sulfur gains 2 electrons. And to form an ion, when it gains electrons, there's electron-electron repulsion. So the electrons are further away from each other. So the size of the ion increases. So you have more electrons in the shell and they repel each other. So they're going to be try and be as far away from each other as possible. So in the case of sulfur, there's going to be greater repulsion. As the next one is, okay, you've got this reaction, phosphorus reacting with O2. What is the formula of the oxide that is formed? A. And they're asking for the equation as well. Phosphorus oxide, what is the formula of phosphorus oxide?
P4O10 or O6.
So there are two options, P4O10, and you've also got P4O6, right? But over here, you're going to write P4O10 because they're using excess of oxygen. So it's going to react completely. So it's going to be P4 plus O2, and it's going to form P4 O10, so it's going to be 5O2, and the rest looks fine. Give two observations you could make in reaction number 2. So what are the two observations that would be seen over here? Okay, first thing, if chlorine reacts, what's going to be seen?
Greenish.
It gets decolorized, greenish yellow gas reacts or gets used up, so it decolorizes. And the second one, what is the color of PCl5?
White.
It's a white solid. It's a white solid. So white solid is going to be, it's going to be formed name compound B. When PCl5 reacts with water, what two acids are formed? Specifically PCl5. One of them is HCl. What's the other one?
POCl3.
Phosphoric acid. You're supposed to name it. It's phosphoric acid, H3PO4. Not phosphorus. Phosphoric acid. Phosphorus acid would be formed if you had PCl3. When PCl3 would react, it would form phosphorus. It would form H3PO3. So moving on, next one, you've got Hanji.
So for part 2, can you write green gas disappears? Or should you write decolorizes?
Nee, that's fine. Both are fine.
And so for part 3, why not POCl3?
Because it's not formed. It's H3PO4. When PCl5 hydrolyzes, it forms H3PO4.
Okay.
So this one, cerium is a lanthanoid metal that shows similar chemical reactions to some elements in the third period. Most of the cerium's compounds contain C3 plus and C4 plus ions. So it shows the same bonding as a typical metal. Draw a label diagram to show that bonding. So what is metallic bonding? Metal atoms, draw them close together, just like O levels, and they will all have, there'll be positive ions because metals lose electrons. And they're going to be tightly packed. So make sure the gaps are as little as possible. And in those gaps, you'll have delocalized electrons, which the metal atoms have lost. And the way you're going to describe this is known as a giant metallic lattice. They're not looking for a description, but it's a regular arrangement of positive metal ions in a sea of free moving electrons. I said ceramic. What are the two properties of a ceramic material? Or 3?
And melting point.
They've got high melting points. And they are electrical insulators. And structurally, they're very strong. I mean, a lot of substances could have high melting points, but structurally they could be weak. Like graphite has a very high melting point. It's got a higher melting point compared to diamond, but it's structurally very weak. It's soft because it's in the form of sheets. Like in ceramic materials, they are. What are the 3 ceramic materials that you should know of? Like the 3 common ones. I mean, apart from this one. Kaun sa tha ceramic? You had. There were 2 ionic compounds which had really high melting point and structurally very strong, and the reason was that the ionic lattice was really strong because they had a very high charge density, positive ions and negative ions. The charge was Mg plus 2 and O minus 2 would attract each other very strongly, and one of them was a giant covalent structure, sand or clay. Because it's a giant covalent structure, so it's got a strong network of strong covalent bonds. So it's also pretty strong. Now the next part is about relative atomic mass. What's the formula of calculating AR? That's percentage, fractional percentage of the abundance or isotope into the isotopic mass, and you sum all of them up. So they're asking you to give your answer to 3 decimal places, and the AR is already given, and you have to find the isotopic mass of the 4th isotope, which is this one. So I'm going to take that as X. I don't know what that is. Can anyone tell me what the percentage is? क्या आ रही है इसकी percentage?
$11.114.
ठीक है, subtract 11.114, right? 11.114%. You can just subtract it from 100. This is this. Subtract these percentages from 100. You'll get that. After you just apply this formula, and you'll find what X is. So the AR is already known. That's 140.116. First one, it's 0.185%. So it's 0.185% into this one. Divided by 100 into 135.907. Then you have 0.251 over 100 into 137.906. Then you have 88.450, 139.905, and then the last one, which is X, the percentage, that's 11.114%. Over 100 into X. And we have to solve for X. You can get rid of the 100 first. तो ये कोई बता दे क्या आ रहा है इसका, ठीक है? Make sure you try and do this calculation. This is a tough calculation to perform on your calculator. So
141.915. 1.915.
And it should be accurate up till 3 decimal places. So that's going to be your answer. One way to check this is, remember the nuclear number and the isotopic mass are going to be very close to each other, because 142 means is the nuclear number. The isotopic mass, the average mass of an isotope, of a proton or a neutron is almost 1, but not exactly 1. So when you add this up, you get something that is very close to 142. So that is one way to check whether your answer is correct. So if you're getting something very close to 142, that would be fine. ठीक है. अच्छा, next पे आ जाते हैं. We've got explain what is meant by the term bond polarity. What is bond polarity?
The unequal attraction between electrons when two different atoms are joined by a covalent bond.
And why is there unequal distribution of electrons? So it's the unequal. That's the first thing. It's an unequal distribution of electrons. Electronegativity is different. Unequal distribution of electrons in a bond due to a difference in electronegativity. And that difference, that results in partial charges, resulting in slight positive and partial negative charges on the atoms. So that is bond polarity. So that's why the boiling point of HF is much higher than the boiling points of the other hydrogen halides. So what type of intermolecular force would HF have?
Hydrogen bonding.
Fluorine is more electronegative.
You're going to write 1 mark would be for that they're going to attract each other. It is obviously more electronegative. That's why it's a very polar molecule, and they're going to form hydrogen bonds. Okay, that's 1. So what type of intermolecular force do the others have? I mean, what type of intermolecular forces exist between HCl, HBr, HIX? Okay, they have permanent dipoles. and also van der Waals forces. The van der Waals forces are always present. So one mark would be for this one, stating what type of intermolecular forces are present. So HF has, and the other mark would be that you're going to state that this is stronger relatively, and permanent dipoles and van der Waals forces in these molecules are weaker relatively. So you're going to state that as well. Thermal stability now of the hydrogen halides. Now it's not about intermolecular forces, it's about breaking the bond between the molecules. So which one is the weakest? Or
HI.
HI is thermally unstable, or what you can state is that thermal stability decreases down the group. So it's thermally unstable. Why is it thermally unstable? Or why does the thermal stability decrease down the group? Why is it easier to break the bond?
Because bond energy down the group is less.
Okay, so you can say that that you've got weaker bonds. Why do you have weaker bond? Because
Bond length increases down the group.
Distance
so
increases.
bond length, distance, same thing. Bond length increases. Atoms are more shielded. Bigger atoms, they're more shielded. So they're not going to attract each other's electrons that strongly. So atoms are more shielded, so there's less orbital overlap. So for example, in the HI molecule, they will be sharing electrons, but they won't be really attracting those electrons very strongly because the ideal nucleus is already surrounded by 53 electrons. So it wouldn't have enough, or it would be so shielded that it will not be able to attract the 54th electron, which is in the shade space over here. So which is why it's not going to be that strongly attracted to hydrogen electrons in the first place. It's too shielded. Now, so you got weaker bonds, and moving to the next one now. Okay, the equation for the preparation of hydrogen halide using concentrated sulfuric acid is shown. So he's saying who's the Bronsted-Lowry base in this one, and we to say theory of acids, identify the base and its conjugate acid. So first thing, who's the base between the two? And you have to explain your answer as well. And what is a base?
Which dictates a H positive ion.
So gone is which one is the base? Okay, that's going to be NaCl because, or specifically it's Cl minus 1, because Cl minus 1 is the one that accepted in H plus 1. So that's your base. And who's your conjugate acid?
HCl.
What's that?
HCl.
HCl.
I think it's the same one, because conjugate acid is that in the reverse direction. Who's losing H plus 1? So it is HCl. Okay, you're going to explain that. You're just going to say that Cl minus 1 accepts, accepts H plus 1 in the forward direction to form HCl, and in the reverse direction, HCl turns into NaCl, or it turns into Cl minus 1, so it loses H plus 1. So you just have to relate this to proton acceptor and proton donor. That's it. As a next one, you've got explain why the reaction of concentrated sulfuric acid. So what happens? This is a very typical group 17 reaction. What happens when you move down the group? What happens when concentrated sulfuric acid and sodium iodide react? Okay, what kind of reaction do you have? Do you have a displacement reaction like this, or do you have a redox reaction? खोल भी ले उसमें क्या होता है कि it's ठीक है, let me just open this quickly. Remember this is inorganic. Cl-1 is a pretty bad reducing agent. It doesn't want to lose electrons because it's a small atom. It has a very strong attraction or affinity for electrons. It's very electronegative. So Cl-1 is not really interested in losing electrons. But when you move down the group, I-1 is a bigger atom. Br-1 is a bigger atom. Br-1 has 35 electrons. I-1 has 53 plus 1, that's 54 electrons. So their nucleus is too shielded that they end up losing electrons. They really like to lose electrons. I-1 is an even stronger reducing agent. So what happens is, this case, what happens is that they are going to have a displacement reaction initially. That all these ions are going to mix up. H plus 1, I-1. Sorry, this is NaI actually, not HI. So in this case, initially, as we've got NaI. So in this case, initially there's going to be displacement and it's going to form NaHSO4. And HI gas would be produced. The ions would mix up and H plus 1 and I-1 will come together to form HI gas. But this I-1 really likes to lose electrons. So what it will do is that sulfur has an oxidation state of +6 and I is -1. I would start losing electrons. It would start forming iodine and sulfur will start getting reduced and it will have to gain electrons and you'll have all sorts of products that will be formed starting with SO2. It might get reduced to sulfur and it might get further reduced to H2S as well. So all these products are going to be possible. So remember your reactions, especially this one, ye bahut dafa aata hai, theek hai? Especially related to concentrated sulfuric acids. We can go over this one more time. Okay, here's the inorganic reactions. So I think it's this one. No, not this one. It is this one. As this part. Remember this comes very often. So you've got NaCl, only displacement happens. The only thing that happens is that NaCl and H2SO4 ions, they kind of mix up in solution and the H plus 1 and Cl-1, they get together to form HCl gas. So you just get a displacement reaction, no redox happens. And you see white fumes or misty white fumes of HCl gas forming in the first one. But when you move down the group, Br-1, I-1, they really like to lose electrons. So instead what happens is that in the case of Br-1 as well, you will get displacement, but Br-1 would start losing electrons and sulfur would have to gain electrons. And the same applies to I-1. There's going to be some displacement, but then there's going to be a lot of redox reaction. I-1 is a really good reducing agent. And also remember that the reason you get a redox reaction is also because of H2SO4, because H2SO4 is a good oxidizing agent. I mean, I-1 likes to lose electrons, but sulfur, on the other hand, also likes to gain electrons. That's why you have a redox reaction. If you don't want a redox reaction over here, in this case, what you can do is you can change the acid. If you instead use a different acid, you might use H3PO4. That's not an oxidizing agent. So in that case, there's not going to be a redox reaction because even though I-1 likes to lose electrons, the phosphoric acid is not willing to gain electrons. So in that case, you're not going to have a redox reaction. So prevent redox reactions, don't use H2SO4, use H3PO4 instead. So coming back to this question, we have the next part, which is, that question is over. The next part is, you've got this reaction and the enthalpy change is given. You're being asked to calculate the enthalpy change of this particular reaction. So what information is provided? The enthalpy change of formation of HCl is given. So we are given delta HF. So what else is given? The enthalpy change of formation of H2O is also given. Okay, what's the enthalpy change of formation of O2 and enthalpy change of formation of Cl2? What value does that have? 0. That's going to be 0. The elements is 0. So basically, we know the enthalpies of formation of our products, and you also know the enthalpy of formation of a reactant. So if you know both of them, the formula is simply that the enthalpy change of that particular reaction is going to be the enthalpy of formation of your products minus the enthalpy of formation of your reactant. So product minus reactants. So we've got 2H2O. So it's going to be 2 into minus 242. And minus the reactants, O2 is 0 and 4 HCl. So that's 4 into minus 92. So what do we get for this?
Minus 116.
Minus 1.
116.
116.
So we're getting minus 116. State the type of catalyst used in this reaction. Explain how a catalyst is able to increase the rate of chemical reactions. It's I don't know details are required, but what type of catalyst? Copper 2 chloride catalyst is added. What type of catalyst is this?
Heterogeneous.
Yeah, that's going to be heterogeneous because it's definitely not a gas. It's an ionic compound.
Yes.
It's most likely a solid, or it's a soluble compound, so maybe it's aqueous as well. So, but at least it's not a gas. The other ones are gases. So your reactants are gases. So heterogeneous catalyst. When the catalyst and the reactants have a different phase or state. So the other part is how does a catalyst work? Now that's going to be very basic because you already got 1 mark, so you just have 1 mark for that. So how does a catalyst work? It lowers the activation energy.
Lowering the activation.
And how does it do that? By providing an alternate path. That's the next one. The reaction exists in dynamic. The reaction was repeated at 1000 with the same pressure. Stain explain the effect on the composition. So he's doing it at 1000. Right now he's doing it at 400. So what he's doing is he's increasing, he's taking it to a higher temperature. So where would the equilibrium shift? And did he tell us which? Acha, the higher temperature concept, it's endothermic, right? So, so we did actually calculate the enthalpy change. So the forward reaction is X, so it's minus 116. We did calculate that. So endothermic is going to be the backward side, right? So you're going to state that high temperature favors endothermic reaction, which is the backward. So your reactants will increase and your products will decrease. That's, I think, what he's asking. State and explain the effect on the composition of the equilibrium mixture. So you'll have more of HCl and more of O2 and less of Cl2 and less of, because the backward reaction is going to be, it's going to be favored. Okay. So this one. Now this one is calculate the amount of moles. So we have to make a table. I would need this equation first. What's the equation? 4HCl plus O2 and so I've got 4HCl plus I've got O2, and I think the products that were formed were Cl2, 2 of them, and I think 2 H2s. So that's my reaction. Now, initial moles first. What are my initial moles in the container?
1.6 of HCl.
So I've got 1.6 moles of this.
And 0.5 of O2.
So 0.5 mole. So take 0.5 moles of this. And I don't think they added at 400. And these are formed, right? So initially he didn't add these. So they weren't there before. At equilibrium, at equilibrium, they're saying that this much is formed. 0.6 of this and 0.6 of this. So you got 0.6 moles of this and 0.6 moles of this. Now to make 0.6 moles, so that means 0.6 got produced, right? And 0.6 of this also got produced. Now to produce 0.6, how much of O2 must have reacted? Okay, what's the ratio? To make 2, you need 1, right?
Half of it.
So to make 0.6 of this, because 0.6 is getting produced, 0.3 must have reacted, right?
Yep.
And similarly, to make 0.6 moles, how much HCl must have reacted? It's 2:4.
1.2.
So to make 0.6, if you want to make 0.6, double the amount of HCl must have reacted. So that's 1.2 that would have reacted, right? So what are you left with? If you started off with 0.5 and 0.3 have reacted, so
0.2.
you're left with 0.2 moles, right? And you started off with 1.6 and now 1.2 have reacted, so you're left with 0. So you're left with 0.4 moles. So you found your equilibrium moles now, all of them, and this is what they were looking for, and you have to find the mole fraction of Cl2 and hence the partial pressure of Cl2 in the mixture. So what is the mole fraction? I'll do it in one step. Like, what's the partial pressure exerted by Cl2? What's the total pressure? The total pressure is given over here. That's 1.5. So it's the mole fraction of Cl2 with Cl2, this one. So it's 0.6 divided by the total, which is, what's the total? 0.6 moles, 1.2, and 1.2 plus that's 0.6.
1.8.
1.8 into the total pressure, which is 1.5 times 10 power 5. So ये वो part है, that's the mole fraction, and the partial pressure is, you can find that. So what's the answer for this?
50,000.
Okay, 50,000 1 by 3. It's, I guess it's 50,000. 5 into T, it looks like 50,000. Next is the partial pressures are already calculated. So all you have to do now is, in this one, all you got to do is find the value of Kp. That's it. So how do you calculate the value of Kp? That's plug in the values. That's it. It's use this information and state the units as well. So you just have to plug in the values, and again, be very careful with your calculator. It's a test about using your calculator. So it's PCl2, which is this one. So it's 3.6 times 10 power 4, and that's squared, into pH2O, which is 3.6 into 10 power 4. And the whole thing gets divided by PHCl, which is 4.8 times 10 power 4. And that's power 4. And PO2, which is 3 into 10 power 4. ये करके देख लो, try what answer do you get?
(1.05 into 10 raised to power minus 5).
So 1.05 into 10 power minus 5. And what are the units? TK, make sure you use the units that I use. It's Pascal, so it's Pascal squared into Pascal squared.
Yeah, minus 1.
TK नीचे क्या Pascal 4 into Pascal. So it's going to cancel out Pascal minus 1. So that's going to be your, so that's going to be your unit. Now, so if you do it without a catalyst, what would be, how would the Kp get affected?
No change.
No change. And Kp gets affected by only one thing. What is that one thing?
Temperature.
Okay, so that's, you're not going to have any change.
Sir, Kc as well, right?
Kc and K, all equilibrium constants. Like, I mean, in AS, that's the only two. That's the only two, right? So they will all get affected by temperature, but nothing else.
All right.
So now this one, let's we'll call it on chart. Take a second.
Sir, regarding the chart for the organic note, yeah. If could you just scroll down to the part where you give all the mechanisms?
Mhm.
Sir, over here, आपने arrows
Yes.
normal है ना? Like, because in the MS sometimes there's a half one or something.
No, I'll tell you, this is I mean, most mechanisms, it's a normal arrow. A normal arrow represents the movement of two electrons, right? So, for example, you've got this one. It's Br-1 lone pair that's getting attracted to the. So it's a full arrow, right? Is that clear? So in most
Yeah.
mechanisms, both electrons are traveling. The bonding, the bond fission or the bond breaking is happening heterolytically. Like both electrons in this bond over here are moving towards the Br, right? Both electrons in the pi bond are getting attracted to the positive H, right? So most mechanisms, it's a full arrow. Okay, there's a half arrow as well, and that's in homolytic fission. That happens in free radical substitution. Remember, if you were to draw an arrow, that's going to be a half arrow, because one electron goes to one Cl, the other electron goes to the other Cl. So that's the only case where you have a half arrow. So इसके अंदर homolytic fission में all of them are half arrows. But in all the other mechanisms, it's a full arrow. So what's happening here? Okay, you've got a halogenoalkane. It turns into a carboxylic acid. This is this part. This is this path. You put a CN instead of a halogen. That's a nucleophilic substitution. It turns into a nitrile, and then that nitrile gets hydrolyzed. So halogen substituted by CN, and the CN getting hydrolyzed by dilute acid and turning into a carboxylic acid. So that's the first part. They've already told us it's HCN and KCN. So one bromobutane is, I'm going to do all the working here. That's 4 carbon atoms. And on the first one, there's a bromine, right? So P is going to be the same thing. It's going to be 4 carbon atoms. And instead of the bromine, there's going to be a CN. And this one is the same thing, except for the CN, 4 carbon atoms, then you had a CN, right? Now you're going to have a carboxylic acid. So reaction number 1 is dilute acid plus reflux. So it could be dilute HCl. So that's how you replace the Br with CN, and then the CN gets hydrolyzed, water gets added and turns into a carboxylic acid. Then the same halogenoalkane will also turn into an alkene. How does that happen? It happens when you have NOH or KOH ethanolic and you heat it. An elimination reaction happens. The Cl is lost, and in its place, the carbon forms a double bond. A Cl is lost and an H is lost. So halogenoalkanes, they undergo elimination as well. So what will happen is, you've got one bromobutane, right? So Br is going to get knocked out, and from the neighboring carbon atom, an H is going to get knocked out as well. So you'll have a double bond over here in the middle. So but1-ene is going to be formed. Okay, the carbon that was making or attached to bromine, it will turn into a double bond, and then that but1-ene is forming a polymer. And you have another one which is OH aqueous. So that is a substitution of halogenoalkane as well. That's where the OH ions. So the halogen will get displaced by OH ions. So that's the same reaction. So instead of one bromobutane, you'll have, instead of the bromine, you'll have an OH. Okay, so now we're going to try and answer this. Draw the displayed formula of compound P. So this one, displayed. When you say a displayed formula, you got to show every bond. So that's P. So it's 4 carbon atoms, and it's got a CN attached. You have to show the CN bonds and show every single H atom. Next one, you've got to identify the reagents and conditions for reaction 1 and 2. We already did that. Draw the structure of the repeated unit of polymer Q. So but1-ene is making a polymer. So how do you make a polymer out of but1-ene? So this is Now this is butanene. The first thing when making a polymer, you draw nothing on the right side or the left side of the double bond. So the H will be drawn downwards. And this carbon branch will also be drawn downwards. So you'll have a double bond. On top, there is an H. On the other one's top, there's an H. This H on the right side will be drawn in the downward direction. And the carbon chain over here on the left side would also be drawn in the. So it's C2H5 or CH2CH3. And they're asking for a repeat unit. So, and just one of them. So the double bond in the middle will break and it will turn into. So that's going to turn into a single bond and it's going to link up with similar repeat units and you're going to write N. TK, is that clear?
Sir,
Haji.
if it said like 2 repeat units, we don't write the N, right?
Then you don't write the N, you just draw, but you always remember
Show
to
the
draw
bonds of
these
continuation
bonds, right?
Yeah. Okay.
I said this one, now he's talking about the mechanism, like, is this a primary halogenoalkane or क्या हुआ है?
N कब नहीं लिखते?
नहीं, अगर वो कहता है कि 2 repeat units draw कर दो ना, तभी even if in that case if you write N, there's nothing wrong with it. Okay, even in this case if you don't write N, that would be fine as long as you show the continuation bonds. ठीक है, but if they ask you to draw 3 repeat units or 4 repeat units, you just draw 3 repeat units and you just put a dash at the end. ठीक है, is that clear?
Yes, sir.
That's the next
So,
one.
sir, in that case, we don't show the bonds of continuation.
You show the bond of continuation. You always show the bond that the structure is continuing. ठीक है?
Right. So, what's different then? What's different then? It's the same thing, no?
Nothing different. It's just that whether to write N or not. Usually N is written with 1 repeat unit. When you show 1 repeat unit, you put brackets and you put an N around it.
Okay.
Okay.
Oh.
But this N, I'm just saying that this N is not important. I'm just saying that if you just show this, that's still fine. There's nothing wrong with it.
Okay, sir.
As the next one, is this a primary halogenoalkane, secondary or tertiary?
Primary.
So what type of mechanism do they undergo? Primary? SN1 or SN2?
SN2.
The primary will undergo SN2 mechanism. In that, what happens is, and the reasoning behind that, the carbon has a very strong positive charge. Why? Because it's not surrounded by large groups. So it doesn't really have a lot of electrons around it. So the positive charge is really strong. And it's kind of open as well. It's not surrounded by large groups. So the OH with its lone pairs is going to directly attack this particular carbon atom. And the Br will get knocked out. So, and that will happen slowly. The OH will approach and the Br will kind of get knocked out. So the next step would be a transition state would exist. And in that transition state, the Br bond would be lengthening and the OH would be coming closer and closer to the carbon atom. And these are your 2 H's. So the whole thing will have a negative charge. So that's going to have a negative charge. It's going to be a transition state.
Sir,
Anji.
for this one, should we show arrows like the OH coming in and the Br leaving? Or
Which one?
for the OH going in or the Br leaving, should we show arrows on the transition state?
You have to show this arrow in the transition state.
Okay.
Okay. But I'm pretty sure that they, in the marketing, they would just be interested in this one. Like complete the reaction scheme to show the mechanism. And the last part is that the Br leaves, right? So you have this transition state and then the Br leaves. So CH3, CH2 and CH2, and then you have a carbon with H's. And you'll have OH and the Br-1 has has left. So pretty sure, how many marks was this? This was 3 marks, right? I'm pretty confident that they were just looking for this one. Yep. So the next part, we've got butanene reacting with steam. There's a major product, there's a minor product. So butanene with steam. So this is butanene. So what's going to be the major product? Water. Where will the H get attached? OH get H कौन सी side पे attach होगा? Right side, left side?
Right side.
Right.
ठीक है. So Markovnikov's rule, the H will always get attached to the carbon that's already bonded to more H atoms. So it's going to get attached. So you'll have CH3 and you'll have CH2. And the double bond will go away and you'll have OH over here and you'll have an H on this side, right? That's going to be your major product. What happens when you oxidize this? What type of alcohol is this?
Second degree.
So it's going to form what?
Ketone.
Ketone.
Okay, so this one will turn into a ketone. It's going to be CH3, CH2. And COH will become C double bond O. The N would still remain CH3. So that's going to be your product. It's going to form a ketone. And this other one, this other one is just the other way around. So it's going to be CH3 and CH2 and the OH will be at the end and the H will be over here. So it's going to form a primary alcohol. So identify the type of reaction. What's the type of reaction when an alkene undergoes, what would you call this type of reaction?
Addition.
It is addition, but what type of addition?
Electrophilic.
Okay, so it's going to be electrophilic addition. And what can be deduced about the structure of S from its reaction with the alkaline aquacidine? So S, which one is S? So S is reacting with alkaline aquacidine. So it's going to react. What can be deduced about it? They actually told you that both S and U react with alkaline aquacidine, this one and this one. So why do they react? Because alkaline aquacidine reacts with two structures. You got a methyl with a C double bond O or a methyl with CH and OH. So if it has either one of the structures, either one of them. So over here you can see, so over here you can see that it's got a methyl group, which is right next to a CHOH. So what will happen is that a CHI3 yellow precipitate would be formed. And the remaining part will turn into an acid. It's going to form CH2 and C double bond O and O minus 1. Since it's an alkaline condition, the acid would lose the H plus 1. Same thing happens over here. The CH3 will break off and it will form a yellow precipitate of CHI3. And the remaining part will turn into a carboxylic acid or its salt. So what can be deduced about the structure of S? That it has this group attached to it. And you just have to state, no explanation needed. So you're going to state that it has this particular structure is present. Right? That's what alkaline aquacidine does. Let's explain why S is the major product. So what's the explanation for S being the major product? Why do you have this as the major product?
Because it has more alkyl
Carbocation
groups.
So the carbocation, because when the H
More
bonds to the
stable?
it's more stable. So when according to the mechanism, the H is going to attack the double bond. It's going to steal one of the electrons, and this carbon over here will become positively charged. It's going to form a carbocation. And in the next step, the OH minus 1 comes in and bonds to this. So a second degree carbocation or carbocation with more alkyl chains is more stable because the positive charge would be smaller. So that is what you're going to write, that in the case of S, you get this carbocation because the H bonds on the right side of the double bond. So you're going to state that a second degree carbocation is more stable. It has more alkyl chains. It's easier to form. Has more electron donating alkyl chains. Hence is more stable. Due to lesser charge density. And draw the skeletal formula of ST and U. I'll just do it over here. That's S is this one, 4 carbon atoms, right? So that's 1, 2, 3, and 4. Plus it's got an OH on the second one. So you got an OH over here. T is the OH is at the end. Again, it's 4 carbon atoms. So that's 1, 2, 3, and 4. And you got an OH on the last carbon atom. This one is a ketone, so it's 4 carbon atoms again. So that's 1, 2, 3, and 4. And there's a double bond O on the second from the right side. So that's going to be my skeletal formula for this one. So that's it, except for S2U dichromate 6. You should use O to represent the oxidizing agent. So they're asking you to write an equation for this one, S2U. So S is CH3CH2. It's a secondary alcohol and it's turning into a ketone. So we're going to write an equation for that. So it was CH2 and then CH, OH in a bracket, and then there was CH3. And this thing turned into a ketone. So that was CH3, CH2, the middle CO, and CH3. And he's saying use O as the oxidizing agent, and you have to write a balanced equation. So what is happening? 2 H's I think are being lost from the middle over here. They're going to combine with the O and it's going to form water. That I guess is about it. So that's your balanced equation. That's it. Nothing is happening to the rest of the molecule. There are 2 hydrogens over here. They get lost, and you're just left with an oxygen, a ketone. So that's about it. Okay.
Sir, can you write the O above the arrow, or should you write it as plus?
You should use O to represent the oxidizing agent. So it should be included in the equation.
Okay.
I mean, you have to write a completely balanced equation. Okay. I said the next one is there's this thing, and it's a colorless liquid with unpleasant odor, and it reacts with methanol in the presence of an acid catalyst to produce an organic compound V. What's happening when methanol reacts with this one? And what's the name?
Ester.
TK, what's the name of the ester? It's
Methyl pentanoate.
TK, this one is methyl pentanoate. And we can try and draw the structure as well because there's pentanoic acid. I think is that pentanoic? It looks like pentanoic acid. That's 5 carbon atom pentanoic acid. And it's reacting with methanol. That's 1 carbon atom with an OH. The OH and the H will be lost. So they're gone. And you got an ester link in the middle. Now you've got a question where methanol and me use infrared, it's about infrared spectroscopy. The spectra will return to the student without labels. So these are the spectra that are given. So they're returned without labels. There's methanol, there's pentanoic acid, and there's V. So first thing, you should remember this. What is this strong absorption at 1600, 1700? What does that represent?
Carboxylic acid.
It's not a carboxylic acid. It's I'll open the data booklet. They're not an alcohol. I'll open the data booklet. I mean, you should just memorize this. This one is very easy to identify.
It is ester.
Not even an ester. It's just serial bond O. It could be an ester. It could be a carboxylic acid. It could be many things. But what it represents is this thing. You got a strong absorption in the 1600, 1700 range. That's a serial bond O. Remember, keep infrared spectroscopy as simple as possible. Serial bond O is the easiest to identify. So you can't really identify a lot of bonds, but serial bond O you can clearly spot. So that's definitely a serial bond O. Is that clear? So this first one has a serial bond O.
Yep.
You got no absorption over here. That means there is no serial bond O, right?
Yes, sir.
And the third one also has a serial bond O. So clearly this one is methanol, right?
Yes, sir.
Because you got three compounds and he's saying that one of them doesn't have a serial bond O. So we know that one of our compound is a methanol molecule. So that is serial bond O, right? So coming back to this table, this one definitely has no serial bond O, right? And this one, definitely it's a carboxylic acid. So it does have a serial bond O, right? And we have no information about V. But you got two graphs with serial bond O's. So this one is definitely going to have a serial bond O by default. Is that clear? Because
So V is the molecule we named.
Are you sure?
Yeah. V in part 1.
That's the ester. I forgot. V is this one, right? So that definitely has a serial bond O. Anyways, the next part, when you get a strong broad absorption in the 3000 region, what is this strong broad absorption? That's
OH of carboxylic acid.
That's the OH specifically of the carboxylic acid around the 3000 mark. So that's OH. So this one is OH from the carboxylic acid, right? This one specifically. So basically this is a carboxylic acid. You got a serial bond O and you got, so this is a pentanoic acid molecule. We're pretty confident about that. This one when you get an absorption above the 3200 range, I mean, this is around 3400. So what kind of OH do you have at 3400? That's a normal alcohol, like it's above 3200, 3400, 3500. That's your normal alcohol. So we've already identified that as methanol. So this one is your alcohol group. So we had already stated that it's got no serial bond O and it's definitely an alcohol. So that's methanol. And the last one is you got a pretty weak absorption. The weak absorption is you also have a weak absorption at the 3000 mark due to the CH bonds. So for carboxylic acid, it's a strong and broad absorption. So this one over here in the last one, that definitely looks like a CH absorption. These bonds vibrating and that's it. So that's the last one is definitely an ester. That's what we have. In esters, you have a C single bond O as well. So I'll just look at the data booklet. You've got C single O, that's 1000 to 1300 strong absorption. So I can see a strong absorption in that range as well. So that's probably C single O. But anyways, we were able to identify that the first one has serial bond O only, and it also has a C single O as well, but no OH, nothing on this side. The second one, it's got an OH, but it's got no serial bond O, so that's methanol. The last one, it's got an OH that belongs to the carboxylic acid, plus it's got a serial bond O as well, so it's definitely the carboxylic acid. Right? Is this clear?
Yes, sir.
Okay, we're done with this paper.
All right, sir.
So
Allah Hafiz.
कल करते हैं, ठीक है? Okay.
सर वो अपडेटेड स्केड्यूल भेज दीजिएगा प्लीज.
हाँ, उस पे मैं लेटेस्ट डाल देता हूँ, ठीक है? ये चेंज कर देता हूँ.
जी, because we only have like 6 days.
ठीक है ठीक है
Yeah, okay. Now,
All right, sir. Assalamu alaikum.
Officer.
हाफिज